All right, I am now recording. Yes. Well, I hope so. I'm in photo booth. Hopefully, I think that records stuff. Yeah, you know, I tested it and it'll record. Okay, so I'm going to talk about Unit 5 because people mostly said on my survey Units 5 through 9 were what they wanted more help with, and then we'll loop back to 1 through 4. Unit 5 is kinetics, so that's like the rate law stuff, and I'm just gonna write some key things that you might not remember and hopefully remind you of. I'll try to notability up these notes so I can send them out too, and I'll link them on that agenda where I sent out stuff. Notability has been a verb, yeah.
It's a verb?
Yep.
Really?
Yep.
Wow.
Okay, so the key thing in kinetics is the rate of reaction. Rate of reaction, which is you measure it like how fast are the products being made or the reactants being used, right? So.
Hi, can I come for like the last half of it? I have to do something.
Yeah, sure. That's fine. I'm recording, so.
Oh, you are?
Yep,
Oh,
I'll post my recordings. So it's like the rate at which products are being produced or the rate at which reactants are being used. So the brackets, remember, means the concentration of products changing or the concentration of reactants decreasing per time. So the units of rate would be molar per second, moles per liter per second. Okay. Not meters per second. Okay. That's the unit of concentration. When it comes to like figuring out the rate constant and stuff, the units for your rate constant, it's important to know that you have to get the units for rate out of your rate law. Okay. What affects the rate just at the particle level is determined by the particles have to collide, right? So increased surface area of the reactant. So if you have a solid and you crush it into a powder, that increases the rate because there's more places for the particles to hit. Okay. Same with a catalyst. Will up your reaction rate by lowering the activation energy. Which increases the rate of the reaction. I'll come back to the catalyst. Temperature, you increase your temperature. That means the average kinetic energy of your particles is higher. So more of them hit the activation energy to successfully react. And the temperature, you might want to note, also increases the rate constant. Rate constant. It actually depends on the temperature. Not anything else. And, also more concentration of reactants. Because there's just more particles in the same space, so they're more likely to collide. Remember that for a reaction to happen, requires your particles to collide in the first place, and with enough energy, which is called the activation energy, and at the right orientation, like the right angle to each other. Okay? Cool. Please just interrupt me if you have a question or if I'm going too fast. I'll go to the bottom board. So rate, this is not ringing any bells. It brings up one bell. Yeah.
But for that,
Yes.
what is Q's with that? Like,
Sure. Yep. That was the next thing I was going to say. So the rate law. So let's do an example reaction here with sample things. your reaction might look like this. Oh, let's put a coefficient d here. Okay. The rate constant, the rate law is going to be something like this. Rate equals some rate constant, and then it depends on the concentration of your reactants to some power. So it'll depend on what the concentration is of your three reactants. And then notice for rate law, okay, these exponents are not necessarily these stoichiometric coefficients. Okay? These x, y, and z, your x, y, z value, that's like we say the order of the reaction with respect to each reactant. Those are usually going to be either 0, 1, or 2. And to know which one they are, you have to either look at experimental data of the rate, or you have to know specifically what the mechanism is for that reaction. Like, what are the elementary steps that cause this overall reaction?
Can you explain that further?
Yes.
And do you always need to know them? Like, will some questions you can just leave them as?
Oh yeah, that was
If
when,
it's not given, what you need to find them.
that was something.
What's not given? Can you give me an example?
You said it's the order of the reaction in terms of what?
So, for example, if x was 1, we would say this reaction is first order with
yes.
respect to reactant A.
Okay.
Or if it's 2, it's second order with respect to reaction A. Or if it's 0, then it doesn't depend on the concentration of A. We say it's 0th order. Yeah.
Because I was doing, because I had written down earlier this year in my notes that like you have to have data to figure out the rate law, or the rate constant. But then I was doing a multiple choice unit 5 in AP Classroom, and they asked me like to find the rate constant, but they didn't give data. So I can find it using the elementary
Right.
like, steps?
Yes.
Okay.
I'll do an example of that. Let's see. Just trying to find. Okay. Determining orders. Yeah, so let's do an example of that. I'll throw up a data table real quick. By the way, I'm working mostly out of this Dingle review book, which is not bad for, it's about $10 on Amazon. I'd also recommend, if you want more practice, I'll put on my agenda there all the old FRQs. But then for good multiple choice practice, there's good stuff in the the Barron's or the Princeton review books where they put like 7 practice tests in there. I pulled some of your test questions from there, by the way.
So you're saying if we had that book, would we have
You may have seen a test question before if you look carefully through all 15 practice tests in those various books.
You mean this one?
Yeah.
Okay, so let me just throw up a data table here. This is from that book. Okay, oh, here, hold on. Let me put the reaction equation that I'm talking about. 2NO gas plus Cl2 gas makes 2NOCl gas. Okay, and we'll look at a few trials for concentration of NO in moles per liter, 0.2, 0.4, 0.2, 0.4. Okay, hopefully this will ring a couple of bells. Concentration of Cl2. You can. Let me just write this down.
Oh, I
Okay, rate. Sorry, I'm standing in front of you. 1.20 times 10 to the minus 6, 4.80 times 10 to the minus 6, 2.40 times 10 to the minus 6, 9.6 times 10 to the minus 6.
So this
Okay.
will all be given.
This would be given to you in a table, probably in a multiple choice question. And they would say, what's the order of this reaction with respect to NO? Or what's the order of this reaction with respect to Cl2? And you would use the data to figure that out. Yes?
Is that a 2 in NO for trial 3?
Yes.
Okay, great. I first thought it was a 3.
That's a 2.
You know what? I've done a lot of
Okay.
today,
Um,
Yeah.
and it was not much.
we know the rate law has to look something like this. Am I in frame if I write over here? Yes. Okay. Rate has to equal. Now I'm gonna run out of room. I'll write it on the left. Rate is gonna equal some K times some power of the concentration of NO2, or sorry, NO, and then some power of Cl2, let's call it Y. Okay? So, your job would be to figure out what X and Y are. So, looking at, the trick is, if I want to figure out X, I need to look at 2 data points where the concentration of the other factors, Cl2 in this case, is constant, but the concentration of NO is different. Okay? So, I can do that comparing trial 1 and 2 from this data. Trial 1 and 2, the concentration of Cl2 is the same, but the concentration of NO is double in trial 2 compared to trial 1. So comparing these two, I've doubled the concentration of NO, and then how does that affect the rate? It quadrupled my rate, which means if I double this number, for the rate to quadruple, that has to be a square. X has to be 2. Right? So X equals 2. Yeah.
Why for trial 4 do we not know the rate precisely? Like, is the reason it's just 9.6 instead of 9.60?
Does that make you feel better?
It does.
Are you hung up on sig figs? Remember, there's one sig fig point somewhere hidden in the free response.
If that's the sig fig point, I don't want to miss it.
No, it's not. I don't know. I just wrote. Ask Dingle. Okay, I wrote what's in his book. Okay, and then you can do the same for. I mean, if you know the trial, if you know X, you can figure out what Y has to be. If you look at, for example, trial 1 and 3 here, there you have the concentration of NO is the same, concentration of Cl2 doubles, and look, the rate it doubles. So that means that's a linear relationship. Y equals 1. Whenever this value doubles, the rate doubles, so it's just raised to the first power.
So you're comparing the change in concentration to the change in rate to
Right.
Okay.
I want to know, this is saying, how does changing the concentration affect the rate? And we said that's the order. X is the order with respect to NO, Y is the order with respect to Cl2. Okay? So, what is the overall order of that overall reaction? 3. It's the sum of the individual orders. So overall, we would say that's a third order reaction. It's second order with respect to NO and first order with respect to Cl2.
What's the highest order for a reaction possible?
Second order. Well, no.
For a reaction
Okay.
overall. Is that
Overall, it can be as high as you want. But for an individual,
What's the highest
Pace.
we ever see realistically?
for these, you will see 0, 1, or 2 on the AP test, and that's it.
Okay, so we would never see like a 5th order overall reaction.
You might, but I mean, for the individual orders for each reactant, it won't be any higher than 2. Okay? Yeah.
So as a function, you could say the amount of rate change divided by the amount of concentration change. Could you
As a function to find this,
not the overall order.
not real. It's. Wait, say what you said again?
To find, well, I guess that's the order. So then how does the order relate to the change in rate?
Because if I say I double the concentration of NO, so I multiply this number by 2, then if I square that, the whole equation is being multiplied by 4, by 2 squared. And so I looked at, just from my rate data, comparing these two, I knew it quadrupled when this concentration was the same, but this one doubled. So that's telling me that x has to be 2, the power there, the exponent.
Do we always need to compare like 1 to 3, or could we do like 3 to 4?
You need to find that. What you want to look for is, if I want to know the order with respect to one reactant, I want to compare 2 data points where the other reactant isn't changing its concentration, right? So I don't want to compare like 1 and 4, because yeah, the concentration of NO is doubled, but so is the concentration of Cl2, and I can't differentiate which of those is affecting the rate.
So it's not about like which one is the first one, it's about like what changes.
It's about what, yeah, you want to have one that's constant and one changing. Okay. Graphs. Let's talk about graphs. That's definitely, absolutely going to be on the AP test. The graphs and order stuff. Okay. So.
It's the lines! I told you!
Calm down, Bella.
I was right.
Order 0, 1, or 2. The rate law looks like this.
Is this on the sheet that they give us?
No, but I can tell you what is on the sheet. Okay. The thing that will give you a straight line plot. They love to ask this question. Here's a graph, or here's several graphs. One of them will be a straight line, and based on that, you have to say the order of the reactions. So a 0th order reaction, your concentration versus time is a straight line.
I told you, 0 straight.
That's what I said.
A first order reaction, natural log of A versus time is linear. And second order, 1 over A versus time is linear.
It's not a crime. It's not a crime to get food.
On the equation sheet, they tell you the reaction law for each order, and they tell them in order. Okay, so in the kinetics section here, I'll put it up for the folks at home. There, that one, okay. They tell you on sheet, they say A at some time t minus A at time 0 equals minus kt. And by looking at this, you should be able to say that just the concentration is linear in time. This one, the log of A at a certain time minus the log of A at a different time is minus kt. And then this one, 1 over concentration of A at a certain time minus 1 over concentration of A at time 0 equals positive kt. Those are on your equation sheet, and they're listed in that order. If you know calculus, you can get this by taking this rate law and integrating it if you substitute dA dt for the rate.
That's how we get to that. Finally, we understand how this happens. Yes.
Yes.
Yeah.
Oh, good,
Same
okay.
class.
So do that on your own time and prove it. Okay.
I'm not going to. But
So
I can prove that.
we talked about collision theory. Okay, so let's talk about mechanisms real quick. Go back to the pump order I did. Oh, yeah, I was too fast. Sorry.
You're right, very fast.
It's on our
It's on the equation sheet. I'm just showing you, like, you can look at the equation sheet. If you don't remember this, look at your equation sheet and just know that it goes in order, 0, 1, and 2. 0th order, first order, second order.
That doesn't matter.
And then say, okay, if I plot which thing versus t gives me a line. It tells you, like,
yeah.
concentration, log of the concentration, 1 over concentration. 0th order, first order, second order.
To be fair, though, it also just makes logical sense.
So if it's 0 order, this is linear. If it's first order, that's linear. If it's second order, that's linear. Yes?
If I don't memorize the periodic table, how bad will that be for me on the test?
You get the periodic table on the test.
But like the names. If
Uh,
I don't memorize like what the letters mean.
that's fine.
I think if you don't memorize.
That is not a good way to spend your study time trying to memorize all the
No,
element
wait, well,
names.
if they ever
You
say
told
it,
us to.
No, hey.
Yeah, well, not now.
like, okay, if they ever say, like, the word for something,
Okay,
that
okay.
letters don't correlate, and you don't know what it is, what should we do?
Do your best. If it's a multiple choice question, answer it. There's no penalty for wrong multiple choice answers. Answer every multiple choice question.
They answer every first
If the first one's question, write anything that might be true, and you might get a point.
I know someone that on one of, like, the AP calculus test, they just wrote, I don't speak English, on one of the questions.
Oh, well
But in
then.
Japanese.
Oh,
It was not correct.
okay. No, it's probably not the answer to your calculus question. Well,
Too excited about that.
let me say this real quick. So,
Even 20 years.
this is not the energy unit, but just real quick.
Just give them online.
There's a hump on that graph as the reaction progresses where this is your activation energy. Okay. And with this is without a catalyst. Since we're talking about catalysts, if you add a catalyst, the change is that the activation energy is lower. With catalyst, I drew in this faint blue marker that is not good. Okay. You might also have a graph. If your reaction takes multiple steps, then it will have multiple humps. Right? So this would be a 3-step reaction, and that one would be the rate limiting step, or the slow step, the one with the highest activation energy. Okay? In other words, the rate law for your reaction is going to be the rate for that step with the highest activation energy. You might see that. These graphs usually are more asking you about delta H stuff, unit 6 stuff, which I'll talk about later. Cool? Okay. Got like 10 minutes? Yes. Yes.
Like speeds up the reaction.
Yes, it increases the rate of reaction by lowering the activation energy.
Okay, that was
Yes.
Does it do not like creating 2 steps to?
Yes.
Yes.
A catalyst takes place in one step, and then it comes back out as a product of a subsequent step.
Yes. And then the
And s-
opposite is where intermediate.
An intermediate would be the opposite, where it's produced in one step and then used up in the next step, so it's not part of the overall reaction. That's called an intermediate.
So a catalyst is always in an overall reaction?
A catalyst goes into the first step of the reaction, and it comes out from a later step unchanged. So then it can be used again. It doesn't get used up. Sometimes people say the catalyst doesn't take part in the reaction. That's not really true. It does by the steps. So let's do the mechanism part. Mechanism. Okay. We said the slow step determines the rate. Slow step determines rate. Sometimes they'll tell you what the slow step is. And so let's say I have an example and I know the mechanism of a reaction. So let's write something generic. A plus 2B makes C, and then C plus 2A makes D. Okay, let's say my 2-step mechanism, let's say this is fast, and let's say this is slow. Okay, the rate law for, if you know the elementary steps, the rate law for the elementary steps does come from the Stoich coefficients. So the rate law for this first step would be K, let's call it K1 for step 1. Concentration of A to the first power, concentration of B to the second power. But only if you know the elementary steps. It's not true in general for the overall reaction. And then similarly for the second one, there would be some second rate constant, concentration of C, and then concentration of A squared. Okay. And since this is the slow step, this is the rate law for the overall reaction. It's the rate law of the slow step.
And what does the slow step mean? Like, it's slow because.
Slow because this reaction has the highest activation energy. So that it's less often that these particles are going to collide with enough energy to make D.
Yes, but if it gets to there, then it's guaranteed to get to the fast step. So that's why. Is that why we determine the overall rate reaction?
Like this would happen quickly in your reaction. You would build up C, but then the C colliding with A to make D. It's like if you're walking down a narrow hallway and there's someone walking really slow in front of you.
Yeah, you can't.
Their pace determines the pace for the whole thing. It limits the rate. Okay, something else to point out. What is my overall reaction? People?
3A plus 2B equals D. Or goes to D.
Yes. Notice that if I want to write the rate law for this, it should be some kind of K overall, some power of A, some power of B. And here I have it depending on C.
Well, we know it creates C.
So you have to substitute for concentration of C, you have to plug in the what goes into making that C. So it would be an A and 2B. So you would do, let's see. We have an A squared already. This would be another factor of A in here. You see that? So our overall for A would be 3 in this case, because I just contrived this example out of my head, even though I said there's no third order before. That's how it works though, okay? And then it also depends on B squared, because it takes 2 B's colliding to make that C that ended up in this rate law. So if you have an intermediate in your rate law for your rate determining step, substitute that concentration for the things that make it up, that go into it.
So the rate law for the slow step has to match the overall reaction?
Yes, yes, that is true. Intermediates that appear as reactants in rate limiting step can be replaced by reactants they depend on.
Because you say it's K.
K, this K would be different potentially than these two.
Okay. So then where did you put the stuff you substituted for C?
So here, let me write it this way. Rate from here equals K2 times C is going to be, the concentration of C is going to depend on the concentration of A, concentration of B squared, and then concentration of A squared again, where this would also have some other K like prime that would combine. That's not that important, but what I'm saying is I'm taking these coefficients, A to the 1, B squared, and that's what I'm plugging in as my concentration of C,
Oh.
right? And then times A squared, and so this and that squared made the A cubed that I
Okay, so
made.
you can't just add the two together.
No.
You have to
Yes.
I don't know if this would ever happen, but if it asked you, if it like gave you that and asked you to find the rate for the slow one, and so you know that that's going to be the overall rate, would you write it as the one substituted without C in it, or would you leave C in it?
If it's asking you specifically the rate for this step,
You can keep C.
I would keep it as C.
But if the slow one is the first step, then you can just use it as the overall?
Correct.
Okay.
Yes. If the slow one is the first step, it's easy. You take that rate law and that's it. Because the reactants of the first step are reactants in your
Right,
overall
you have to
equation.
rate.
Okay, that means if you have, well, yeah. Okay. Okay, so real quick, just catalysts. I didn't say a catalyst with a mechanism. So let's say we had A plus B makes C, and then C plus D makes E, and I get A back out. So that if this is my step 1, and this is my step 2, I've got A going into step 1, I've got A coming out the same out of step 2, so A is a catalyst. That's how a catalyst works in the mechanism.
And the only thing it does is lowers the activation energy.
It lowers the activation energy because my overall reaction here would be A plus B plus D makes E plus A. So this part is a catalyst that we can ignore. If you just had B and D colliding, that would have a higher activation energy than either of these two steps. So by adding A, instead of doing this directly, I take it in a different mechanism. The reaction happens in a different mechanism with lower activation energy. So the catalyst does take place in the reaction, but it just comes back out a later step unchanged.
One question just back from the top. Why is it that the temperature changes the rate constant? Is like the other ones just change the rate? Or like
Maybe because their kinetic energies are they like touching each other more?
Yeah. There's an equation, the Arrhenius equation, tells you this connection between temperature and the rate constant, but it's actually not part of the AP test, so you don't have to know. Yes? Temperature, concentration, a catalyst, or what else did I say? And surface area of a reactant. Those 4 things will increase reaction rate.
how much of unified did you use? Like, was that the majority of it, or is there like?
I think that's the majority of it that you'll need to know. If I think of anything else, I'll add an addendum to my recording.
One of the chair abusers during lunch now.
Who's that?
Brady.
Does
Oh.
he abuse first chairs or second chairs?
All of them.
Third chairs?
All of
Third
them.
chair?
Any other chemistry related questions?
Hi, Los.
Um,
Thank you. Have a good day.
Why is hydrofluoric acid bad for dissolving bodies?
Please record.
Because it's a weak acid. It's not a strong acid.
I finally got around to watching
I will record the
Breaking Bad.
Zoom, yes. Hit me up on Zoom tomorrow if you want to learn about Unit 6.
Also, he said we're alike, so I don't know which of us should be offended by that.